As you know, the Dallas 2030 district promotes energy, water, and transportation sustainability in Dallas. Did you know that the Dallas 2030 district is one of a handful of groups that actually measures our progress? In our 2018 annual impact report, we decreased our energy use by 17.4% from the baseline. And in our 2019 annual impact report, we decreased our energy use by 18.4% from the baseline. This puts the Dallas 2030 district well on its path towards achieving our 2030 target of reducing energy use overall by 50%. We are very excited by the progress we have collaboratively made so far and looking forward to another great year. This is possible because of our amazing members. Hopefully, we will have our 2020 annual impact report in the coming months. Please feel free to reach out if you need any additional information or would like to participate in the district. The Dallas 2030 district was created to facilitate the operation of buildings, particularly for energy, water conservation, and transportation utilization. These functions all impact and depend upon building systems and operations. In the recent past, the interest in healthy and sustainable buildings has grown rapidly. The current health pandemic has made those health factors even more important to buildings. This existing building system needs to be optimized. New technologies are being offered and promoted to improve healthy building operations. With that, I would like to introduce both of our speakers today. We have Jerry Kettler from FPA, and we have Dan McLaughlin from FSG Lighting. We're going to get started with Jerry. So Jerry's going to do the first part of this session.
Okay, we get the slides up.
Can you see the screen?
I see the screen, but I'm seeing the city of Dallas. I'm not seeing our slides.
Okay, there we go.
Okay, there we go. Thank you. Thank you for joining us. A lot of us had a little problems last week, and a lot of what we're talking about today is going to relate to that, and also relate to our little health crisis that we got going on, and hopefully give you some hints and things with some late information, some stuff that's just happening. And Dan and I are going to cover a series of different subjects. So next slide. So what we're going to be talking about is buildings, as pretty much everybody here knows, are complicated. There's a bunch of systems, and those systems have to work together. And the point there is those of us that both build and operate buildings need to consider the entire building, the entire site, when we start changing and operating things. But there are ways of analyzing performance, and we're going to go over some of those, and figuring out from the various systems, how are you going to optimize? How are you going to be sure that they operate right? So we're going to be covering some hints on that. And then there are some options, some other things that will impact productivity and health. Particularly, that's the main thing that we're talking about here today. We're talking more about health and performance in a building as opposed to efficiency today. So those are the kinds of things we're going to be talking about. And the building codes and the building standards are starting to react to these things. And we'll go over that a little bit. So next. So a couple of things to think about, just from a context standpoint, to step back and look at why we're looking at buildings. Because people are the reason that we have buildings. If we didn't have people, we wouldn't have buildings or wouldn't need buildings. So the buildings take care of the people and the things that people need to do and the things that they need. But the people that are in the building react to want to have a healthy building. And we're seeing more and more of that in the literature and in building operation, is the people want to have a healthy place to come to. They want their experience to be positive. And what we're going to talk about here in a couple of minutes, I'll show you an interesting study that says that the occupancy of a building and the experience, the health of a building, affects the productivity of the folks in the building. Now, there are some programs that most everybody knows about, of course, LEED, that LEED is more comprehensive. It's been around since about 2003. And a lot of our buildings have been associated with LEED, but it's more comprehensive. In the last few years, there's a new system called Well Building, and it's more health oriented. It's a very good program. They got 10 categories, including food and recreation and all kinds of things. But it starts out with air quality and also then goes to water quality. So it talks about the same thing we're talking about here today. It's a complex program. A simpler program that addresses health also is one called Fitwell. And if you need more information on any of those, let us know and we'll help you with that. But as I mentioned before, codes and standards are starting to react to these things. International Code Council is starting to adopt some of the things in the ASHRAE standards, which means that they're getting more and more technical, more and more things to do, more and more things to watch. Center for Disease Control and ASHRAE have recommendations that we're going to be covering a little bit on how to start and how to operate buildings with this health issue. So those are things all associated with what the people are going to need. Then you look at buildings from a strict building operation. Of course, codes and all that started out as basically safety requirements. But buildings, as the codes have evolved and buildings have evolved, the buildings have changed a bunch since I started working with buildings 50 years ago. So the things are much more complex, but the functions in the buildings have changed. Computerization wasn't there when I started with working with buildings. And the efficiency category, once we had the oil crisis back in the 70s and 80s, started talking about efficiency. Well, efficiency and health, we have to look at as a balance. And I'm sure Dan will be saying a few other things about both. But the codes and standards have to do not only with buildings now, but with health. So let's go to the next slide. One of the things to do is to take a look at what the people functions are first. What are the occupants' needs? And it's that most anybody that operates a building knows that people in the building have attitudes, and they also want to participate. So the key to a lot of the things that we're going to talk about today is training, is communication, is informing folks. As building management, you talk about occupant management. In this case, from a pandemic standpoint, everybody's heard about the masks and the hand washing, the distancing, all the rest of that. And a lot of this is affecting how the buildings are operated, and it's going to affect how the buildings are designed and how they're used in the future. Another thing that is getting more emphasis is janitorial work, maintenance work, ongoing things. And there are some hints and things that we're going to be talking about here this morning that might help you with some of that. But the whole idea is that people need the support of the building, of the physical facilities. They also need to have the supplies, and in some cases it might be building modifications to make things safer and more healthy. All of that gets back to, and we're going to be spending a lot of time talking this morning about equipment tune-up, operation, and that sort of thing in the context of health and occupants. So next. This is a interesting study, and if you wanted, it's done by Harvard University, and if you wanted a copy of the standard, you can actually get a copy of their report. The title is up on the top, the COGFX study. Go to the Harvard website and go to COGFX study. They're on the third stage or the third level of research at this point, but the first two levels, you can get a copy of the report. What they did, you can see on the slide and the picture on the left side on the top, looks like a cubicle office. Well, that's what it is. But in that office, they can control the atmosphere in the office. And the picture on the bottom is on the floor below. That's how they're controlling everything on all of this. And they got 24 folks, and they tested things over 6 days. and they tested things at 3 different levels. And what they were doing was testing the performance of the people with 3 different air conditions. And the only things they were changing were volatile organics, VOCs, and CO2. CO2 being a surrogate for cleanness in the space. And they ran what they called a conventional office, which was sort of dirty. Then they lowered the VOCs, and then they lowered both and had some interesting results. They're checking cognitive functions. We'll show you this on the next slide. So what they did is conventional office, carbon monoxide or carbon dioxide at 1,000 parts per million, which is about the ASHRAE recommendation for where you shouldn't go above. And then 600 micrograms of volatile organics. Then they lowered the volatile organics, and they lowered both of them. So the next slide shows you the results of this. And what they did is for each level, they measured the performance of these 24 folks in information usage and all of these things, crisis response, focus activity level. And if you, interesting, if you look at the enhanced green of the top level, every one of the performance areas went up based on increased quality of the air in the space. And again, they were only changing 2 items, the VOCs and the carbon dioxides. But look at the information usage and the strategy on top. Nearly 300%, 3 times better performance with good air. So there's a good reason that we want to have the air in our space to be as good as we can make it. So next. One of the things we have to find out on each building, every building's a little bit different. And in order to maximize our individual buildings, we need to look at each individual building. What's it used for? On an existing building, is the building being used for the same thing it was designed for? Quite often they're not. What are the functions of the folks in the building? So you would need to look at that. Where is the building? Is it located where you can get good fresh air, where you can get good water? So age and location of the building are important. How many people are in the building, and their schedules will determine your outside air and your temperatures and humidities and all the rest of that requirements. And also you have to pay attention to what kind of equipment, what kind of contaminants, what kind of whatever are the occupants bringing in. So the whole idea there is we got to respond to what the occupants are doing. So that sets our ventilation and environmental requirements. What is going on in the building? How many folks are there, and what are they doing? Now, to a certain extent, that affects, of course, as we mentioned, cleanness and janitorial. All the rest of that is going to have to reflect what's in the building. And in the end, we're needing to do more requirements, more records, more things we have to keep track of. So the whole idea is figure out what's in the building and what your building really needs. So next we'll talk about buildings. Building terminology. So there's interesting evolution here. Life safety is a building back in the 60s and 70s when you start having building codes. Life safety was the issue. Building code and structural code was the first codes. And then from that building code, they also tacked on the plumbing and the mechanical code and the electrical code. But then in the 80s, we got into the energy efficiency area. And then it was more general than just efficiency, about performance. Well, that was good. That was good for some years. And then all of a sudden we changed to the green terminology. That's one of the, it's sort of a terminology. LEED was the one that sort of led that version or that area. But people stopped liking the term green, so they started to use sustainable. Sustainable is more broad than green. And then lately it's been net zero. So this is an evolution that the buildings have gone through, and it started slow, but some of these changes in the last 2 or 3 down there are starting to do change pretty quickly. So let's go to the next one. So the codes and standards and the guidelines, as I mentioned, building code was the start. Now all of these happened. The electrical code, of course, that was the energy code is actually based on an ASHRAE standard, ASHRAE 90.1, that just changed. There's some interesting changes that are happening in the energy code. The regional NITCOG committee is looking at the new energy 2021 energy code for the region at this point. The green code, which only the city of Dallas at this point has adopted, is based on the ASHRAE 189 standard. And that's a evolving thing because that ASHRAE committee, there's about 80 or 90 people on that committee. So there's a lot of changes. There will probably be codes for resilience based on what happened the last week with the power and the water and the rest of that. I think we're going to see more activity and more regulation and more opportunities there. Next. So the building systems we're going to talk about today, and we're not going to talk about plumbing and electrical too much. Air conditioning, these are the basic processes. Air conditioning, we're talking about ventilation, comfort, and ultimately health. And of course, plumbing, pretty obvious that you need water, and pretty much obvious that you need light. And Dan's going to be talking a lot about the electrical and lighting area and how it relates to what the air conditioning is doing. So next. So one of the things we have to do is, in addition to figuring out what the building needs, people in the building need, is to take a look at our systems. First thing is it working? Is it functional? Is it operating? Is it clean? So we've done some surveys on, particularly on schools. Schools seem to have one of the biggest problems of keeping things working and keeping things clean. So functionality, is it working? Then is it doing what it's supposed to do? Your temperature, your humidity, your outside air, is it providing the requirements, the needs for the people in the building? Then does it meet what's supposed to be in the building? Then do you meet the standards from the codes or whatever? Existing buildings have to meet the codes that they were built to, but adapting and adapting buildings to the newer requirements is quite often beneficial. But also it reflects efficiency. How much does it cost to operate the building? So how much of this can we utilize to tune up the building? Do we need to modify it? Do we need just to tweak it a little bit? That's some of the things we need to look at here. So next. So divided this up into basically about 4 levels. If you look at building evaluation, the ASHRAE, both the ASHRAE standard and the DOE requirements, you've got level 1 and level 2 energy audits. But if you look at the ASHRAE commissioning documents and their standards, particularly for existing building work, it's in 4 levels. Planning, and we'll call it level 1, 2, and 3. But the planning, you have to set the goals. What do you want the buildings to do? First, you have to assess it, we just talked about. Then you have to verify that, test it, implement that to be sure that it's actually doing or what flows and temperatures and all the rest of that, you got it. Then you make recommendations and then you implement the ones that you want, the ones that you need, the ones that you can afford. So I also created these into an assessment. You got to do that. You can't really change a building unless you know what the building's doing. But verification is more complex. Testing and the existing commissioning, you should do that activities. And the implementation, like I mentioned, there are things that you might want to change, you might want to upgrade, you might want to put a new system in. So next we can go into some detail. So level 1, I'm saying must do. This is basically your building assessment. And we're doing some of these now, and it gets to be quite interesting. If you have somebody outside of the building, outside of the organization, come in and take a look at what's going on, you can learn some interesting things. On the must do, you walk through and says, what's working? What do you, if the building has been turned off because of shutdown of the pandemic, you have to say, okay, let's make the systems operational. You turn them on and you clean them, because air gets stagnant a little bit, and water particularly is a problem. If the water stays in piping, say in a building, and they're having this problem with the sanitation of the water, the chemicals in the water deteriorate over time. So if you have very little water flow, your chlorine content of the water pretty much disappears by the time it gets to the end of the pipe. So if the building's shut down, you've got to air it out. You got to take care of the water too. And when you do that, you might make minor tune-ups. You might make adjustments. You need to be sure that all of that's working. And then you put a list together. Figure out what you need to test. Some things are working fine. Other things, whether it's outside air units or cooling towers or whatever, may not be working as well as, or you don't know exactly how they're working. So you need to put a plan together to verify that performance. Then you need to find out from whoever the owner or manager is, what do you want to do? How far do you want to go on this? And the next one talks about the verification stage. So these are things that you should do. Periodically, you should test and recommission the projects and the air handlers and the cooling towers and the chillers. That's the only way you really know, with testing them, whether they're doing what they're supposed to be doing. And then you have to create what we call a current facility requirements. We talked earlier about, oh, by the way, you need to figure out what's going on and what's needed. And there's a documentation process called current facility requirements, where you document all of these things. And then you have to perform whatever minor adjustments and all the rest of that you can do as far as the verification part of it. And then take a look at your O&M plans and your programs. Do they do what they're supposed to do now as opposed to when they were written? And then if you have to retrain people, you do that. So then you develop options and changes, and then you get agreement that you proceed from that. So the next level, you look at things that you might want to change. So next slide. There you go. So things you might do: modify existing systems, implement testing on new and revised systems. Things that you might want to do. You might want to put new systems in. You might want to put new filters. You might want to put new air handlers in. So there are things that you might want to do that'll improve building performance. But if you do any of that, you need to update your systems. You need to update your O&M manuals and your maintenance plans. All the rest of that affects it. So let's get into some detail on a couple of these things on the next slide. So if you go back to the pandemic issue at this point, there's a series of things that they want you to do that both the ASHRAE, by the way, the ASHRAE site has a building restart in a pandemic. There's a bunch of things on the ASHRAE website that are really, really good. They've got about a 20 or 30 page set of recommendations that are really good. So if you haven't accessed the ASHRAE site to do that, that's a good location. But they want you to clean things. They want you to maximize the ventilation that the units can handle with outside air volume, so you get air flushing, increase the filtration efficiencies, but that isn't always the easiest thing in the world to do. Then take a look at the scheduling and set points, control humidity levels. One of the interesting things here is there's a reason that flu and viruses and that happen a lot in the wintertime, because the humidity level is low. What they found is viruses grow better in dry conditions. So if the building's dry, the viruses are going to thrive better than if the humidity is controlled between 40 and 60%. Then you upgrade things when you need to. So next. So ventilation analysis. you have to take a look at your outside air. Can you increase it? What's the existence of outside air, the connection? Does it exist? If you're using a lot of small split systems in some buildings like schools, you can't increase the outside air. What is the capability of that system to put in more outside air? Because you can't just totally open the outside air vents on some systems because the units aren't designed to handle that. So you need to go back to the design level and see what's capable. And then you program things, adjust things. Again, testing and commissioning are good ideas to make the thing work the way it was supposed to originally. So the whole idea is make things work like they're supposed to originally, then figure out if you can improve things and get better performance. So there are equipment limitations you have to look at. So next slide. So on ventilation, these are the kind of things you might want to look at. You look at what are the sensors doing, what are the controls doing. Do you have dedicated outside air units? Are they clean? Are they doing what they're supposed to? Building pressurization. You need to keep the building pressurized all day long, 24/7, to keep leakage and contaminants from the outside coming in. So there are systems, for example, if you're building residential units now, the energy codes require pressure testing. Those pressure test requirements are now starting to go into the building codes. So we're going to have to start pressure testing buildings when they're built. So you need to take not only that building, but the ductwork. Then the air handler systems have new motor systems, and the rest of that you need to take a look at with their capabilities on outside air. Then, of course, an exhaust, how are those controlled? And I'm skipping over these pretty quick so that Dan can have as much time as is necessary to explain all of his good systems. So next. So ventilation is these are the standards. The ASHRAE 62.1. Good, it's ventilation standard. ASHRAE 55, which is just republished. It's about temperature control, humidity control. Then contaminant control gets into a whole bunch of things, including testing. Air quality testing is a whole subject on its own. If anybody needs information on air quality testing, let us know. We can probably help with that. But thermostats have changed. Technology has changed. Soon we will have wireless thermostats. The thermostats will be mounted on the ceiling. So there's a whole bunch of things happening in the controls world. So Internet of Things, a lot of things are going to be controlled. I've had some interesting conversations with the BACnet folks. If your building there won't be a computer in the building anymore. The building controls will be controlled by something in the cloud. And which is an interesting thing, is if it's a cloud-based control, what keeps somebody from Moscow or Peking from taking over your building? So there's some interesting questions on that. And it gets back to the Internet of Things. So next. So filtration. We got the outside air coming in as we can, but the present filtration can be 1 to 4 inches. But changing the filter, the better filter you get, the higher the pressure drop. So you have to be careful that whatever you change the filter to, the air handlers will handle. University recently decided to change, they sent the directive out, change every filter in the university to MERV 13 or 14. And so a lot of them could only handle 1-inch filters, so they really high pressure drop, and all of the direct expansion systems in the university froze up. So couldn't do it. So be careful of what you try to ask for. But if these are the ranges down here, the MERV 6, 8, 11, 13, MERV 13 is what LEED and some of the other codes or standards are starting to require. But you can see there that the MERV 6, the 1-inch 35% filter, handles the big parts, 3 to 10 microns. The MERV 8 gets better. It'll start down to the 1 micron. MERV 11 doesn't have a real big pressure drop as opposed to the 13. But by the time you get to the MERV 13, and you can get 2-inch MERV 13 filters, the particles go down as far as what you can catch. So next. This is gives you an idea of what we're talking about here. PM10, most filters can take that. This is the comparison of the blood cell right next to it. PM 2.5, relative size. The better filters can catch the 2.5. And you can see the relative size of the bacteria, but look at the relative size of the SARS COVID-19. Really small. It's 0.1 microns. Isn't caught by most filters. So next. So this shows you, and I might spend a lot of time on that. This is the various filter levels, but you also need to keep track of, the MERV ratings only go up so far. And they only go up to 16, but some people are saying they got 17, 18, 19 MERV. There's the national ASHRAE standard for testing of filters, 52.2, doesn't go above 16. So be careful if you get into the high efficiency filters. So next. So this is a summary area for microns. You can see that until you get to MERV 8, you're not going to get down to the anything less than 3 microns. So you're still going to have fine dust. So when you get all the way down to 16, you can get some pretty good filtration. But keep in mind that the viruses are about 0.1 micron to 0.2 microns, so you're still not going to catch those. So I think we can go to the next one. And we're going to let Dan take over now and shed some light on the UV situation.
Thank you, Jerry.
Thank you so much, Jerry.
Yeah, we appreciate it, Jerry. Well, welcome, everyone. I'm just going to kind of parlay on what Jerry was talking about as far as the air efficiency and the cleaning of air handling units, filter maintenance, safe airflow, because the biggest challenge we have today is showing people that are coming back into our buildings that they feel safe, that we're taking steps to cleanse the building even more than we used to. So when you look at disinfection using UVC or ionization, these have been around for years. They've been used in hospitals. They've been used in traffic areas where they were worried about bacteria. Now, because of COVID, we're in a brand new area where they have excellent opportunities to be utilized in every facility to help all those people feel safe in your facility. Next slide, Selena, please. Let's look at how is COVID passed on. We all know we have to wash our hands and we have to try to keep our masks on when we're out. But if somebody's in your building, an affected individual, they sneeze, they talk, they sing, all those different things that happen, the droplets have a tendency to go airborne. So all of these things are going in your systems and they're going through your air handling units. And so, and in addition to washing our hands and wearing our mask, we have to look at indoor air quality. Next slide, Selena. So this is just how far can they travel? So you're saying, if they cough, and people cough. I mean, where are we in DFW right now? We're going to be into the allergy season. We might say, everybody, oh my gosh, Corona, go away. But that's pretty much from all the different things we have, and ragweed and everything else, elm. But those droplets will go 160 feet. So they're going to go in your air intake. Same thing with sneezing, singing. This is just an idea of what we have to look at for the next phase. Yes, we can disinfect our have the cleaning people come in once a day and disinfect our spaces, but we need to look at more than that as far as making people feel safe. Next slide. So again, this is just a visual of how the droplets do pass through the circulation buildings. This is what we're going to be looking at now with UVC lighting. And go ahead, Selena, next slide. So what can we do to disinfect your facility? Next slide, please. So there's two ways to do it. You can utilize UVC lighting and HVAC ionization systems. Many buildings, again, hospitals have had UVC lighting for years, typically on a lower wavelength cycle, a 222 nanometer, that actually kills bacteria. However, with the COVID and the SARS viruses, those are not disinfected or deactivated or even killed using that lower UVC lighting. We have to go to a different higher volume of UVC lighting, wavelength. Same thing with the ionization systems. These have been around for years. They're proven systems, but we've never looked at using them in commercial office buildings or schools or where people congregate. Next slide, please. So I'm just going to touch on some of these, and certainly down the road when we get over this, if you want to get some other information, we'll be glad to help. Or you can actually talk to, if you've got an HVAC company you do business with, talk to them as well, because we're all offering these now and are able to help you with these. So number one, let's look at UVC lighting. How do I know that it is effective against COVID-19? Well, there's plenty of studies. These are just, I'm not going to go into detail with these, but there's plenty of studies showing that UVC, looking especially with 254 nanometers, reduces the SARS viruses and any kind of SARS virus or COVID virus by disinfecting it. What the UVC light does is it disengages their DNA, so it makes them inert, makes them inactive. Next slide, please. These are, again, recent studies using it. They know that you can put these in facilities, you can put them into spaces, which were great at disinfecting spaces and countertops, and it also does your air handling units. Go ahead, next slide as well. I'm going to go pretty quick because I don't want to tie in these, spend a lot of your time. So UVC light basically prevents microorganisms from reproducing by damaging its nucleic acid. So it's a non-chemical process, does not leave any residuals. It's just light. And the light is actually disinfecting those spaces in your building so that you don't have, you're taking that out of the air. You're taking the virus out of the air. Next slide, please. I know I'm going quick, sorry. So what's the difference between UVC, UVB, UVA, and far UVC? And next slide. So as I've said before, the 254 nanometer is for germicidal UV. Some of you may actually have some of this in your facilities now. I did actually a call a couple of weeks ago, and people had some UVC lights, 4-foot tubes in their air handling units, and they've been there for a long time. And they work great, but what people don't know is those lights have a finite life. They're basically good for a year, maybe 2,500 or 3,000 hours. And after that, they're not doing anything for you. So when I said before, on the one of the far UV on the left, the 222 nanometer, that's not a visible light, but it's also not harmful for people. So you can put that in a ceiling, but that does not kill any viruses. It's only good for killing mold, fungus, and bacteria. That's what they've been using in hospitals for years. So if we go to the next level of 254, it doesn't activate viruses. It kills bacteria, mold, and fungi, almost 100% effective, but the exposure time is short and is proven. Unfortunately, you cannot be in the same room as when those are on. You can't be in there it damages your eyes, it damages your skin, it gives you way too much UVC. And so we have to make sure that people are not in the space when that happens. Some of the other ones, UVA and B, have been around a long time. A number of our suppliers actually have UVA lamps and UVB lamps, which are great. But again, what we're looking at specifically today is how do we remove the viruses, the coronaviruses, the SARS viruses from our space. You cannot do that anyway, but from either the UVC, which is 254 or 222. Next slide, please. So what UVC options are offered today? Again, I know probably a lot of you looked at these. If you worked on budgets last year, you were saying, hey, what are we going to do to get people back in our building so that they feel safe? I mean, matter of fact, the articles today, a couple of recent articles are saying that they anticipate that 80 to 85% of people will go back to work in buildings, but it is changing how the spaces are being used. You may see this with some of your tenants where they want larger spaces, more spaces between people. They want sneeze guards, and they want lots of different things to make sure that people are going to feel safe coming in there. So some of the most popular products are portable carts, and you can disinfect particular areas. So, and other items that I'm going to show some of these here, but there's portable air purifiers, in ceiling fixtures, in ceiling air purifiers. There's actually escalator handrail sanitizers, elevator fixtures. They actually have mirrors with UVC light below to sanitize the sinks, and actually you can actually put them under your sink as well. Next slide, please. This is just a sample of there's a lot of places that maybe have a big space and they want to be able to have a mobile unit where they can put this in their space and it comes on for a specific period of time. Again, you go back to these are operated remotely. They have sensors that shut off whenever they detect movement within the space, because you cannot be exposed to the UVC lighting in the 254 nanometer. But if you're in this particular cart, does in 60 minutes, it will disinfect a 20,000 square foot space. Now, the nice thing about the UVC light is it not only does some of the air that's in the facility, but you're actually disinfecting anywhere that light touches. Any counters, any tabletops, any computer desk, any computer terminals, any phones. So everywhere that the light touches, it disinfects. And as you see, this has replaceable lamps, about 100,000 hour life for something like this. I'm just going to show you some samples. Next, please. Here's another portable unit that can be done for small areas. A lot of these are good for public spaces, conference rooms, big auditoriums that you use for your clients, or even the public spaces where they go in there and they have little restaurants and different congregating spaces. So portable is good. You can actually put it in there, move it around your space, turn it on, let it run, and somebody can move it, depending on the square footage. If it's 1,600 square feet, an hour later, they move it to another space. Again, they're remote activation, sensor shut off, and again, replaceable lamps. Now, some of these UV lamps, if you start getting into the 4-foot lamps here, they're 12,000 hour life. So it doesn't take very long where you're going to have to make sure that you have maintenance and repairing the lamp that's in there. These can also be done via Wi-Fi. You can control them and see what's going on with them. Next slide, please. So what advantage does UVC have compared to the foggers? A lot of people are using foggers in their space. Their cleaning people are coming into the space daily. I've talked to a number of cleaning folks through some of the organizations, and their business is booming because anytime somebody gets a hint that somebody has a coronavirus, they're in there spraying all the spaces. But here's the problem. A lot of these are chemicals, weekly, monthly, or depending on your coverage area. You have to have additional cleaning, labor. There's chemical residue left, probably. I mean, we're spraying a lot of chemicals in these spaces, and a lot of times you have to wait quite a while before they're and people can get back in the spaces. And you're only disinfecting the surface, whereas UVC lighting will do surface and air. Next slide, please. So this is just pictures. I mean, it's good. Really, the ideal situation is it's a three-pronged approach. So you have your cleaning people coming in and doing their daily quick spray disinfection of those spaces. In addition to that, you may utilize a UVC light either in the space or even mounted on your air handling unit to keep your coils clean, which is keeping bacteria and the viruses off of those as well. And then we'll look at the next part, which is needlepoint bipolar ionization. Next slide, please. So how do I know which cart, if you're going to do, it's interesting because how do you know which cart, or if you're going to do your lighting or what's going to be disinfected in the space? They actually have this VRA analysis, which is pretty similar to doing a lighting layout of the room that shows you how many foot candles you may have. Many of you know what that is. So next space, just to show you some, next slide, please. These are some different maps done of different spaces. It shows you the irradiation time to kill 99% of the virus in the space. And obviously, the farther away you are away from the light, the longer it's going to take to cleanse those spaces. So middle of the room, it'd be ideal. You clean it both ways. So this is what you probably want to look at if you're looking at some kind of a room UVC light and how that's going to affect that space. Next slide, please. Again, here's typical classroom, which can be done for office spaces the exact same way. This is just a VRA map of what the disinfection is, how quickly it's done. Again, the farther away you're from the lamp, the longer it's going to take to clean. Next slide, please. Again, here's another one here, just a bar grill area, for example, in your building where you may have restaurants. How if you use a cart, how long is it going to take to disinfect that space? And if you're going to have to do that every night or every day when everybody's not in the building. It's just a choice that you can make to use these, or you can do other things as well. Next slide, please. Typical office, 10 minutes, 10 by 15 office. You put that in the middle of the room. There's a lot of other portables besides this. I'm just showing a few, and there's many small units that'll do a 10 by 10 space, or larger units that'll do this space or even a larger space. Next slide. Again, here's church and auditorium, or perhaps you're doing an auditorium. You have a big meeting room, a meeting space. This is just more towards some of the other places that you can look at, but it gives you the general idea of we can do a layout as far as how the cleaning is going to be done in that space. Next space as well. Here's one where there's a 26,000 office space, 26,000 square foot, where different UV lights are put in either portable areas, or sometimes in these spaces you can also mount permanently on the side of the walls spaces that clean them when nobody's in there. The other advantage is a lot of these lights can be hooked up to your building automation system. So it can all be done when nobody's in the space. You can also track how long they're running and what they're doing at all times. Next slide. So other ones, some of the things we're doing, we've done UVC lights on air handling units, and that's really what you want to do to keep your coils clean, and that's probably the best way to use it. Typically on its own, UVC does not cleanse air, and you have to be careful because you have to be careful in the space that it's either up high but it's only cleaning a portion of the air. Since we utilize UVC when it's empty, what can be done while the space is occupied? This is pretty exciting because really helps people feel safe. We're looking at a number of installations right now. We've actually done some. So the second part is installing ionization system in the HVAC units. And this can be done by your own people. This can be done by somebody like FSG, an electrical contractor, or it can be done by your HVAC person. Next slide. So what is ionization? Typically outdoors, ions are in the air outdoors all the time. So they say, why do people want to have functions and they want to do more meetings outside? Because naturally occurring ions are more when you're outside. There's usually between 2,000 to 3,000 ions, positive and negative, per cubic centimeter outside. When you go inside, that's greatly reduced. So what NPBI, it's called needlepoint bipolar ionization technology, it safely cleans your air inside your buildings. It uses an electronic charge to create plasma filled with a high concentration of positive and negative ions. As they travel through the air, they attach to particles, pathogens, and gas molecules. They do the fine sub-micron particles, they make them filterable. So they make them larger because the ions attach to the dust, the VOCs, and then they kill the pathogens. They actually take the hydrogen molecule out of viruses. It just deactivates them. So once that ion hits that virus, it makes it's not a virus any longer. So it's real easy to do. Now, here's the thing. One thing with ionization modules, if you get over 12 volts, you can create some ozone. So you have to really look at modules that do less than 12 volt. And then that way you don't have the ions in your field. So the ions produced travel within your system into the occupied space, and they clean the air everywhere around the ions travel, even in spaces and on top of countertops. Whenever those ions hit the countertops, they continue to give you an extra layer of protection on the countertops. Next slide, please. So what is needlepoint bipolar ionization? So an ionization system combined with a MERV 8 filter is actually equivalent to a MERV 13 fixture. So it's less strain on your HVAC system and less airflow. Now I'm going to put a caveat in here. The CDC still says that even if you're using an ionization system, they recommend a MERV 13 filter at this point in time to disinfect the air. So that's certainly based on whatever way you want to go on that, but a lot of people are still using MERV 13s. So the ionization also prevents the buildup of organic material in your coils. So you got less maintenance. You're disinfecting the entire coil length, not just the line of sight. There's no harmful byproducts. It's totally safe. You're talking about oxygen, nitrogen, carbon dioxide, and water vapor. These are auto cleaning and maintenance free. Available sensors, it can be hooked on to your building management system, and they only use 15 watts or less per unit. I haven't put, let's see, let me do it here. So if I look at this, I wanted to show you, this is actually, don't have a green screen behind me. This is a, see if I can get that. This is actually a unit right here. That's non-cleaning. It's no maintenance on this, and this will look up a 12.5 ton unit. So once you put this in there, and this is producing a max, this is producing over 200 million ions per cubic centimeter, and pushing them down your air handling units and going down the ducts into the spaces. It's amazing. And if you have a bigger air handling unit, these are smaller units that we can take up to as long as we need to. And these, like whenever you clean the filters, you just run a brush on them to clean them. Go ahead, next slide, please. I will tell you this, that the NBPI benefits, and many of you may be looking at stuff today on ionization modules because there are a lot of companies that are making them right now. Some of them are very expensive. They want to put boxes on the top of your air conditioning units. They want to put all these other heaters and all this other type of stuff in there, almost prohibitive as far as the cost. What this needlepoint bipolar ionization is actually very inexpensive. Again, it's particle reduction. You have odor control. So it takes your odors out, the VOCs out of the air. It has pathogen control, and you have energy savings by being able to reduce your outside air reduction. Next slide, please. So how do you know needlepoint bipolar ionization works against COVID-19? I'm going to go ahead, 3 quick reports. I know Salima will actually be able to have this slide presentation too. You can look at some of these. You can actually do your own investigation, but go ahead, next slide, Salima. So here's laboratory tests on bipolar ionization, neutralization of COVID, SARS and COVID viruses. So you probably won't click there, probably won't work on it, but we can also present some of these. By the way, also, and I should probably post this out there, we've got a couple of sites. We have, if you go to www.uv-videos.com, uv-videos.com, FSG has a number of shared videos on there on both UV and the needlepoint bipolar ionization modules. And it'll give you a lot more information. I know enough to make sure that I can share it with you. I'm not an expert like Jerry is by any stretch of the imagination, but we have access to those experts. So next slide. Again, there's another, so here's some more test results. So sensitivity testing, they talk about norovirus, Legionella, human coronavirus. Then they go simulation testing on tuberculosis, Staphylococcus, MRSA, E. coli. This shows, and we can come up with these tests for you, is that this needlepoint bipolar ionization modules do actually go in, disinfect your air, just deactivates the viruses, keeps your air cleaner. And so when you can actually go back then and put that out there into your clients and the people that are in your building, the visitors, the people that are renting your space, and say, this is what we're doing to keep your space safe, so that people want to come back into the office. I know we all want to get people back in the office. This is not going to change. The UVC lighting and the bipolar ionization, the ionization modules are going to become they're going to be probably part of all new designs, and they're certainly going to be a part of all redesigns and upgrades right now as we go. So next slide. So this is back to Jerry's. I mean, to do what he said before, increase quantity of the air, do different things for your building, determine what the building and occupants need, and investigate your current standards for building and people in building, test the equipment and verify performance, determine what system meets the needs, tune up and make improvements or additions, UBC, needlepoint bipolar ionization modules, train your occupants and operators, and document, including testing and operation. And by all means, you want to share what you're doing so that people know. We're just not sitting here. It's just like in the past, everybody lead building. People want to be attracted to buildings that are lead, that are looking at doing those things to operate a little differently. And they want to improve the space and save energy. Well, this now improves the air and improves the comfort and the safety of the people that come in the building. Next slide. And I think that's done for me. That's done for me and for Jerry. again, you can
Just,
reach out to either of us, and for any additional information, if there's any questions, we'll try to answer them.
Just one quick comment, that a lot of information on a lot of different systems here. But my main recommendation would be to look at everything and look at your building and decide what you want from a system standpoint. So that some of these things work better in various conditions. And as Dan mentioned, don't believe every ad you see. And you know, have verification and you know, get some experience, because just putting things in because somebody showed you something sometimes doesn't work real well. So, and I'm sure Dan would agree, is that you have to look at the entire system. You have to look at the performance and do something that makes sense for your building.
Yes, reach out to professionals who have experts that can bring people into play to make sure you look at different options to make sure you're picking the one you think is going to do the best for your facility, your owner, your tenants, all those folks.
Got more questions? Our email addresses are there. Just shoot us an email.
Thank you so much to our speakers for taking the time to present to us today. We really do appreciate it.